My name is Lawrence Galitz, and I'm going to explain now why banks delta hedge. We saw earlier in this course the delta hedging process. If you sell a call option, the bank has to buy the underlier in order to hedge the delta. And if market prices go up, they have to buy more. If the market price goes down, they have to lessen their hedge. And it's an ongoing, continuous process. It's actually quite a hassle. So why do it? The answer is essentially risk management. And I can demonstrate by means of the examples I'm just about to show. What we have here is a Monte Carlo simulation where we tried 3 different hedging strategies. One was the full delta hedge. In our simulation, we simulate 1 year of option hedging. It's a year option. We simulate delta hedging twice a day. So if there are 250 working days, there are 500 occasions where the hedge is adjusted. So that's one strategy, full-on delta hedging. Let's compare it with the complete opposite, no delta hedging at all. You might liken that to a sell and pray strategy, where the bank sells an option and then prays that the option expires out of the money. Now, no bank in real life does that, but let's explore what would happen if it did. The third is a kind of halfway house, if not quite halfway. It involves executing an initial delta hedge, but then no further dynamic delta hedging. And we're going to explore the outcome in each case. The example we have is a 1-year option where the fair premium for an at-the-money option is $5.40 on an underlier of 100, so a 5.4% 1-year premium. Rather than charge the fair premium, the bank obviously has to make money and adds 10%. So actually, the net cost to the client is $6 even. If the $5.40 fair price implies a volatility of 20%, then the actual price quoted to the client, $6, implies 21.5% volatility. We're going to explore the outcomes under each of those scenarios. And the first one we're going to explore is the sell and pray, no delta hedging at all. The outcome is summarized in the first column of the table. Now, the interesting thing is that the result you get is a 60-cent profit, which is exactly what you would expect if you sell an option at $6 when the fair premium is $5.40. So on average, it's the expected result. But the average can be very misleading, because when you look at the extremes, you see that on the one hand, the best outcome is that the bank collects the $6 premium and gets to keep it. The option expires out of the money. But the worst outcome is a loss of almost $124. And that, considering a $6 premium was charged at the outset, is a very considerable payout. How that loss arises, if you do no delta hedging at all, is the underlier, which starts off at 100, at one stage rises and continues to rise until at expiry, the underlier has reached $250. It is possible. Even if we assume 20% volatility, there is a statistical opportunity for the underlier not only to double, but to increase by 150%. So if at expiry the underlier is at $250, the client who owns the 120 strike call will exercise it, will hand over $120 and get an underlier worth $250. So that's $130 of loss. It's mitigated by the premium charged up front of $6, but that's still $124 of loss. Ouch. It's for this reason that banks don't simply do nothing when they sell options. They want to avoid this tremendous potential for risk. Let's explore the next alternative, which is doing an initial delta hedge, but then doing nothing. It's still pretty bad, but it's half as bad as the worst outcome. And the reason is, in this case, the delta of the option at the inception is approximately 50%. So the bank buys half of the underlier. So in that scenario where the underlying asset price goes from 100 to 250 at expiry, the bank has already bought half of the shares it needs to deliver and only loses out that tremendous amount on the remaining half of the exposure. So the statistics of risk, worse outcome of around $67, and the standard deviation now $6 and not nearly $11, those risks are halved. But the best outcome in terms of risk management is doing full delta hedging. Every time the underlying asset price changes, the bank buys or sells in order to mitigate the risk. And you'll see from the result of the simulation, the worst outcome has improved from a $123 loss to a $67 loss, now to little more than a $2 loss. So the worst outcome is much more under control. The standard deviation also expresses that as well. And you'll see that the standard deviation of results is now just over 30 cents. Compare that with $6 or almost $11. You can see these outcomes on the charts. The no hedge at all strategy is the red profile, and it has this enormous cantilever going out to the left, representing the low probability but potential to make a very large loss. Doing the initial delta hedge is the blue profile, and that's better but still has a considerable degree of adverse exposure. If you continually delta hedge, you then get the purple exposure. And we've drawn an inset into the chart showing the full extent of the distribution. The result is never worse than a $2 loss or indeed a gain of a similar amount. The risk is under control. And the reason is, if the underlying asset price starts to go up, by dynamically delta hedging, the bank buys more of the underlying asset. So by the time the underlying asset price has risen more than a certain amount, the bank is fully hedged and loses no more. So banks dynamically delta hedge in order to minimize the risk and keep risk under control. Of course, it's not without costs, and that has to be balanced in their strategy.